Hi everyone, in this video we're going to be looking at the role of electronegativity in determining the ionic or covalent nature of bonds between atoms. So before we do that, we should define what electronegativity is. It is the ability of atoms to draw electrons to themselves. And if we have a look, we've got a blank periodic table here, and electronegativity increases as we go up a group in the periodic table, and it also increases as we go across a period. And so that means that the atom with the greatest electronegativity is fluorine. The noble gases are not considered because they have, as we know, a stable octet electron configuration. And fluorine has an electronegativity of 4. Cesium over here is considered to have the lowest electronegativity, and it has an electronegativity of 0.7. So at this point you might be asking yourself, okay, so where are these values from? So they're from a scale which we call the Pauling scale, which is a rating of atoms' electronegativity from the value of 0.7 to 4. And so electronegativity is going to have a really big influence on what type of bond will form between two atoms. So we have a high difference in electronegativity is going to result in the formation of ionic bonds, because one atom is going to have, if we have a look at, how do ionic bonds form? They form between a metal and a nonmetal due to the formation of ions. Okay, in our previous study, we've learned what ions are, and they are charged particles, okay, or charged particles, or atoms, could be molecules that are charged as well. We won't go into too much detail. So they're either going to have a positive charge or a negative charge. And the reason why is because an atom, for example, sodium, has essentially donated an electron to chlorine, which has gained an electron. And so they become the sodium ion and the chloride ion. So sodium being at this point here in the periodic table, it's going to have quite a low electronegativity in comparison to chlorine, which is over here, group 7 underneath fluorine. And so the great difference between the electronegativities, which means that chlorine is going to be able to actually pull the electron off sodium's third energy level completely and form ions. So the value that we look for when we're doing any particular calculation, which would just be the difference between the two electronegativities, is a value of greater than around 1.8, 1.9. Different sources will say different things, okay? And so that's what we're looking to do. If we have a medium difference of electronegativity, what is going to happen there is that we're going to have a type of covalent bond called a polar bond, polar covalent bond, which essentially the word derives from the word pole, which means opposite ends. And so this could be, for example, this could be the bond between oxygen and hydrogen. So hydrogen's over here. Off the top of my head, I actually do know these electronegativities. That's 2.1, and then oxygen over here is 3.5. So if we did the math, we would go, okay, 3.5 minus 2.1 is going to give me an electronegativity difference of 1.4, and so that falls within the range. So what does that mean? That means that in this bond, the more electronegative oxygen is going to be able to essentially draw these two electrons, this bonding pair of electrons, toward itself more readily. Okay, and so in an electron cloud, I'm just going to make a bit of a mess here. If I'm representing the electrons, they're going to spend a greater amount of time around the nucleus of oxygen than they are around hydrogen. And so it's going to be an unequal sharing of electrons. And so the way that we denote that, or the way that we would show that if we redraw the bond over here, would be by denoting that with a delta negative sign. Okay, and I always think to myself, delta and negative means slightly negative. It's not an ion, so it's not completely negative. Okay, it hasn't taken the electrons for itself. It's still sharing with the hydrogen. But this is the more electronegative atom, okay? And so that is going to be a region of slightly negative charge, and the hydrogen is going to be a region of slightly positive charge. So with vectors, we would draw the arrow pointing towards the more electronegative atom. And then finally, our last option is a very low difference in electronegativity. That out, which is around less than 0.5 of a difference. And what that means, all that it means is that these two atoms that are bonded together have low difference in electronegativity, so they've got the same ability to draw electrons to themselves. So a really easy example is a diatomic molecule of any atom that we know forms a diatomic molecule. So take chlorine, for example. So it's got the same electronegativity for each atom. And so the electrons are going to be equally shared among the atoms, So we call that a covalent bond. But because it doesn't have a positive and a negative area, we call it a nonpolar covalent bond. And what we would need to do for any two atoms is we would just need to find the difference if given the scale. It would always be given the scale, and you would be able to find the difference between the two atoms and then work out which category does it fit in. If it's a high difference in electronegativity, it's going to form an ionic bond between the two. And the big clue is it's going to be generally a metal and a non-metal. A medium difference in electronegativity is going to form a covalent bond that is polar. It's got a negative and a positive end, even though it is still sharing electrons. And a low difference in electronegativity is going to form a covalent bond where the electrons are equally distributed between the two atoms, and we call that a nonpolar bond. And so I hope that has helped you in determining the role of electronegativity in the formation of bonds and the type of bonds that they form.